On number 1 right here, we have a system of equations, and we want to use any method we want to solve this system. Now you could guess and check, like what is x and what is y. That'll work up here, and that'll work down here. That'll give you a true statement on both. But right here, the easiest method I would say is substitution, where you take what y equals and plug it into the equation you have not used yet. So let me zoom in and do that. My new equation right here, my new bottom equation will be 4x plus y, but instead of y, I'm going to put the above 5x plus 1 right in there, equals 10. Okay, so from here, since we plugged it in parentheses, there's nothing to distribute. I don't need the parentheses. So what I really have is simply a 4x plus 5x plus 1 equals 10. So when we combine like terms, 4x plus 5x, that's 9x. Bring down the plus 1 equals 10. And then solve it the way we normally would. Subtract 1 here, subtract 1 there. You will get 9x equals 9. And then from there, you'd have to divide by 9, which means that x equals 1. And you have one answer, but you need the other. So at this point, I would rewrite any of the two equations. I'm going to go with the top equation, y equals 5x plus 1. But instead of x, notice that I put parentheses. And the reason why I put parentheses instead of x is because I already have an x value, x equals 1. So I'm going to take this 1 and plug it right into here. I might as well show arrows right into here. So I have a 1 right there. So that means that y equals 5 times 1, that's 5, plus 1, y equals 6. So ladies and gentlemen, the answer to this system is the coordinate 1, 6. Your x value is 1, your y value is 6. Now, I want to pause it here. All right, so let's try number 2 right here. It's another system. On this one, we're not going to use substitution. We're going to use linear combinations. I want either the r's to eliminate or the t's to eliminate. But if you just combine them right now, negative 6 plus 3, it doesn't cancel out. And negative 6 and negative 6, it doesn't cancel out. So you're going to have to modify maybe one equation or maybe both equations. I want to modify one equation only. And you have to decide what you want to cancel out first. What do you think is easier, to cancel out r's or cancel out t's? T's are a little bit easier. Because if you multiply the bottom equation, or how about this? Let's multiply the top equation by negative 1. Then that way the whole top equation, when you go negative 1 times negative 6, that becomes a positive 6r. Negative 1 times negative 6, that becomes a positive 6t. And then negative 1 times 6, that becomes a negative 6. So modifying that top equation, I now have a positive 6t, which will cancel with this bottom negative 6t. So the bottom one, I'm just going to rewrite it right here. That's going to be 3r minus 6t equals 15. And now I am ready to combine the lines, eliminate the t's, and I will have 6 plus 3, which is 9r, equaling negative 6 plus 15, that's 9. So I have 9r equals 9. And when I divide by 9 and divide by 9, I'll get r equals 1. So that's half of our answer. We know that r equals 1. We still need the t value. So all we need to do is plug that into any equation we want. I am going to go for the bottom equation, 3r. But you know what? Instead of r, I might as well write the parenthesis right there, because I'm going to end up plugging in my 1 value, minus 6t equals 15. So all I did was rewrite my bottom equation, but instead of r, I put parentheses, because I'm going to take the answer, r equals 1, and plug it right in to the r position, r equals 1. So now let's do this math. I have 3 times 1, which is 3, minus 6t equals 15. And then I would subtract 3, and I will have negative 6t equaling negative 12. No, positive 12. So my final step would be to divide by negative 6 and divide by negative 6, which means that my t value is what? In this case, my t value is negative 2. So now I know my answer to the second one. My answer is the coordinate, alphabetical. R comes first. 1, comma, negative 2. That's my answer for number 2. Number 3. So right here we're going to be graphing inequalities. What's the key to graphing lines? Y equals mx plus b. But on top of that, you need to determine if it's a solid line or a dotted line. And then on top of that, you have to either shade above the line or below the line. So it's a good idea to use different colored pens if you have it. I want to use my red pen to do this first inequality. Now, when I think of y equals mx plus b, I hope you guys remember this. The b value is the y-intercept. And then from that b value, so we know that it crosses the y-axis at 2. And then from that point 2, you're going to rise and run according to the fraction that's right here. It doesn't look like a fraction, so let's just put it over a 1. Let me do a different color. Put it over a 1. That way we know we're going to be rising negative 2 and running 1. So rising negative 2 means you're going to be going 2 down, and you always run to the right, and it's over 1. So we put a dot right there. You're going down 2 over 1, down 2 over 1, etc., etc. Backwards, up 2 over 1 to extend it the other way. Now you ask yourself, is this line going to be a solid line or a dotted line? What do you guys say? Is this line a solid line or a dotted line? Dotted. Exactly. It's dotted because it doesn't have the solid line underneath it. If it had a solid line underneath it like this one, then you would do a solid line. So right here, it's going to be a dotted. So, and I am doing this in red. I'm putting some dots right here. Now, I either shade in above the red dotted line or below the red dotted line. The shortcut is to simply look at this inequality, and what does that mean? Above or below? Greater than is above. So we're going to shade in above. So when you shade in, I would just do it lightly. Don't get too crazy, all right? Just lightly shade this in. Now the reason why I say don't get too crazy is because you still need to ignore this graph and graph the other one in a different color if you have different colors. If not, it's okay. But let's graph this other one in blue. And this one crosses the y-axis. Here's the y-axis. It crosses at the b value of 3. So up here is where it crosses. Put a dot right there. And then from that point, you look at your slope, which is in front of x. And in this case, it's 1 over 1. So if you go up 1 over 1, up 1 over 1, up 1 over 1, you're going to be off the graph. So you're going to use that pattern backwards to extend the line the other way. And then after that, you need to ask yourself, is this blue line going to be dotted or is it going to be solid? Definitely solid because it has a solid line underneath it. So when you draw your solid line, you end up with this blue solid line. And then you have to shade either above or below this blue solid line. So what do you think this is? This above or below? This is below because it's less than. Less than is below. So you shade in everything down here on this side of the blue line. If it would have been greater than, you'd be shading in above. But it says less than, so you shade in below. Now, again, you do it lightly because what really matters is your overlap piece, all right?
Oh, you have to do it through the red one too?
Yeah, so where's the overlap piece? It's right here. All of this right here. This is what really matters. So on your multiple choice answers on the midterm itself, you're going to see this solid, this dotted, and this is the only thing you're going to be seeing shaded. It doesn't really show you this or this, right? This is not shaded at all. This triangle is only shaded once. This is only shaded once. This is the overlap piece. That's why this is the only thing you're going to see. The only thing that matters is the overlap piece. You get it? Number 4, listen up, guys. You're going to have one of these on the midterm. It says the sum. What does sum mean? Plus. And we're going to be adding 2 numbers because they don't tell us what the numbers are, but they tell you that their sum is, which means equals 98. So if you have a number x plus a number y, it's going to equal 98. I hope everybody's with me here. Yeah. Now, the other one, or the other statement says, and their difference is, which means equals 12. Now, difference means what? Add, subtract, multiply, divide. What does difference mean? Subtract. So if I take the same numbers, x minus y, and I put 12 right there because that's their difference, I now have a system of equations that I could solve. I now have a system of equations that I could solve.
Where'd you get 12?
Well, because on this problem it says their difference is 12. So their difference is 12. So now that I have this set up, I'll be able to combine the lines, linear combinations. The y's eliminate. X plus x is 2x. The equal sign comes down. And 98 plus 12 is 110. So I have a simple equation, one-step equation. Divide by 2, x equals 55. So once you have this first answer, x equals 55, you need to plug it back into any one you want to solve for y. So I'm going to plug it into the top equation. X plus y equals 98. But I'm going to take this 55, which is x, and I'm going to plug it right in here. So my new equation is going to read 55 plus y equals 98. And then I'm going to subtract 55 on both sides. And I'll get y equals 43. So what are the numbers? This is what it's asking. What are the numbers? Well, you're going to say x, actually 55 and 43. I mean, the x and the y, we just made that up. But that's your answer for number 4 on this one. Moving on. Now this next one, there's 2 parts to it. So it says, solve the system by graphing, then state the solution. Now, this is not inequality. These are just 2 regular lines. And if you have different colored pens, it's great to use these different colored pens right now. I want to do the above one in red. I want to do the below equation in blue. Now, the one in red, it's already ready to graph. It's already in y equals mx plus b. So you start with the b value at 3. It crosses at 3. Let's put a dot at 3. And we're going to take that dot, and from that dot, I'm going to rise and run according to my slope. Remember, y equals mx plus b. The b value is your y-intercept. I already put a dot there. Now I need to look at my rise over run to see how much I rise and run from this red dot. So my slope, my fraction in front of my x value really is negative 4 over 1. So it's going to go down 4 units. Down 1, 2, 3, 4, and run 1. You always run to the right. The rise, if it's positive, you go up. If it's negative, you go down. We clearly see this is a negative fraction. So I'm going down 4 units. 1, 2, 3, 4. And you run 1 unit to the right because it's over 1. And we put a dot right there. Now, I could continue to go down 4 over 1. Down 1, 2, 3, 4 over 1 to get my line all the way to the edge. And I could go backwards up 4 over 1, but that's really going to be off the graph, so I'm not going to do that. I am going to draw my line through it, and it's not an inequality, so it's the equal sign. You are going to have a solid line going right through it. And now let's graph the other one. The other one, I need to get it ready to graph. It's not in y equals mx plus b. It has a 2 in front of the y. You don't want a 2y equals mx plus b. You just want y equals mx plus b. So let's get rid of that multiplication of 2 by dividing everything by 2. So I'm going to divide by 2, divide by 2, divide by 2, and I'll have a new equation that reads y equals negative 4x plus 3. Now this is something really weird because when you start graphing this thing, you go to your b value, which is right there, the same dot. That's weird. And then you're supposed to rise and run according to this slope, which is down 1, 2, 3, 4 over 1. And guess what? It's the same line. Right? So it's like if one line landed perfectly on top of the other line. It's not that they're parallel, because remember, the whole purpose of graphing equations is to find the point that is in common. So if they're the same exact line, they have an infinite amount of answers because there's an infinite amount of points in common. So that's what we write as the answer to to this one right here. The answer is infinitely many solutions. And the explanation, why is it infinitely many solutions? Because it's the same line. There's an infinite amount of points in common. It's not just this point where they cross. It's not just this point. Every single point on each line is shared with the other one. Why? Because it's the same exact line. So I guess on this section, all you have to do is make sure that they're both ready to graph and y equals mx plus b. And if you end up with the same exact equation, you know you're going to have an infinite amount of solutions that are the same. If I take a look at 5b right here, the above one is ready to graph. Let's graph it in red. It crosses at -3. From that point, I'm going to rise and run according to the fraction in front of x. So if I rise 1, run 3, I'll end up right here. If I rise 1 and run 3, I'll end up off the graph. If I go backwards, I'll end up over here and off the graph over here. Actually, over here, sorry. But anyway, you don't have to go off the graph. This is a solid line. There is no shading because it's not an inequality. Let's look at the bottom equation. The bottom one's definitely not ready to graph. I want to do the bottom one in blue. Let's get in y equals mx plus b form. I'm going to get rid of the minus 2x by adding 2x and adding 2x. I will have 6y equals 2x minus 6. So for my final step, I'm going to divide by 6, divide by 6, divide by 6. I will end up with y equals, reduce 2 over 6. It becomes 1/3 x. -6 divided by 6 is -1. So there's my new blue equation. Now what does that mean? That means it's going to cross the y-axis. The b value is -1. That's where it crosses the y-axis. Put a dot at -1. And then you're going to rise and run according to this slope that we have on our slope-intercept form equation. Rise 1, run 3. Rise 1, run 3. You end up with that blue dot right there. And you could use the pattern backwards to go this way. But, to go this way. And as you could see, we end up with lines that are perfectly parallel. Now, we kind of already knew that because the slopes are the same. And when you have the same slope, the lines will not intersect. So if we're looking for the point that they share, we're looking for the point of intersection, and they don't cross, what do we say? We say no solution. No solution. You can say no sol, no solution. And the reasoning for that is because the lines do not cross. See, you want to find where they cross. If they crossed right here, that would be the solution. But if they don't cross, it's no solution. So I guess question number 5 on this practice test is just to get you used to looking at a system and understanding those special cases. This hardly happens. It's rare. But if I put it on this practice test, that means it is coming out on the actual test. So infinitely many solutions if it's the same line. No solution if they're parallel. If they don't cross, there's no solution. Now, some of them, they will cross at one point, and that'll be your solution. Let's take a look at number 6. This one's fun. This is back to reviewing Rule 1 of exponents. Ladies and gentlemen, all you have to do is recognize that in this whole thing, it's nothing but pure multiplication. So you don't even need the parentheses because there's multiplication between the 2, but there's multiplication between the I and the J, between the H and the I, between the 7. There's multiplication here, multiplication everywhere. So because there's multiplication everywhere, you could rearrange it. That's a commutative property of multiplication. 2 times 3 is the same thing as 3 times 2. So you could rearrange it, and that's what we're going to do. I want to put the -7 and the +8 together. -7 times +8, that's going to give us a -56 as the beginning part of our answer. But then I want to write h to the 9th times h. H to the 9th times h. I could put to the 1 if I'd like. And then I'm going to put the I times I to the 7th. I to the 1 times I to the 7th. And last but not least, I'm going to put my j to the 8th with my j to the 5th. J to the 8th, j to the 5th. So I'm really putting everything in order so I could do what I can. -7 times 8 is -56. H to the 9th times h to the 1 power, that's h to the 10th power, Adam. That's rule 1 of exponents. And then I to the 1 times I to the 7, that's I to the 8th. And last but not least, j to the 8th times j to the 5th. Add those, you get j to the 13th. So ladies and gentlemen, this is my answer, but you don't need it to be all those different colors. Negative 56, h to the 10th, I to the 8th, j to the 13th, and that's it. Let's take a look at number 7. 7, 8, and 9 are all dealing with rules of exponents. Actually, 10 and 11 also. As a matter of fact, I want to pause this video right here. I'll start my next video up on this next section with rules of exponents, even though technically 6 was also rules of exponents.